Hello everyone, welcome to the second session of hydrocarbon. So today we will discuss the properties of alkanes, physical properties and chemical properties. So first of all, let's see the physical properties of alkanes. So among alkanes from C1 to C4, C1 to C4 means from methane to butane, they are in the gaseous state. Okay. And from pentane that is from C5 to C17 which is liquid state, and all higher alkanes are in the solid state. So first of all, remember the physical states of alkanes according to the carbon number. And then texture wise, they are colorless, odorless. They don't have color, at the same time they are odorless, and they are non-polar. Alkanes are actually non-polar, and that's why when we will mix alkanes with water, it do not dissolve in water, because we know water is a polar solvent. So only like, okay, that combination will take place. Polar with polar and non-polar dissolve in non-polar solvents. That means this non-polar, since alkanes, that is hydrocarbons, alkanes are non-polar, they won't dissolve in the polar solvent water. So please remember, they are immiscible with water. Okay. And boiling point of alkanes, as the number of carbon increases, normally the boiling point of alkanes is increasing. Boiling point increases with increase in the number of carbon atom. But here an exception is that if branching occurs in case of alkanes, if branching occurs means the boiling point will be decreases. That means let's consider the example. The alkanes with same molecular formula, that is C5H12, that is pentane. So let's consider the normal pentane, CH3, then CH2, 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 CH3. This is normal pentane, and consider neopentane. Okay, so neopentane is CH3, C, CH3, CH3, then 1, 2, 3, 4, and this is also CH3. Okay, so this is neopentane, and considering this normal pentane and neopentane, boiling point of neopentane is less than that of normal pentane. Boiling point of neopentane is less than normal pentane, and why this difference occurs means as branching occurs in case of a molecule, its intermolecular force become weaker. That bond strength of the bond decreases as if the branching occurs. At the same time, surface area of the compound is decreases. Therefore, so branching, what change branching causes in the boiling point of an alkane means branching occurs. As branching occurs, therefore the boiling point is decreases. And why branching decreases the boiling point means, which decreases the weak van der Waals force of attraction between the bond is decreases. At the same time, surface area of the molecule is decreases. So these are the major physical properties of alkanes. Let's move to the chemical properties of alkane. So among these chemical properties we will discuss different types of reactions could be undergoes by this alkane. Okay, so mainly first chemical property, substitution reaction. Alkanes can undergo substitution reaction. So what is substitution reaction means? In a chemical reaction, one atom is replaced with other atom or other group is known as what? Substitution reaction. So alkane can undergo substitution reaction, and the hydrogen from the alkane, the hydrogen atom is replaced by other groups like nitro group, halogens group, then sulfonic acid group, etc. Okay, but for us only halogenation is there. Substitution reaction with halogen is given in our syllabus. That's why we will learn halogenation. Halogenation means it's a type of substitution reaction where one of the hydrogen from the alkane is substituted with any halogen. That reaction is known as, that substitution reaction is known as what? Halogenation. Okay. So halogenation, we know these are the halogens: fluorine, chlorine, bromine and iodine, and the order of reactivity of halogens is given here. Fluorine, reactivity of fluorine is greater than chlorine, bromine and iodine. But for the halogenation reaction, always we will prefer either chlorine or bromine. Okay, during halogenation reactions we will prefer always either chlorine or bromine. But why we'll neglect this fluorine and iodine? Because reaction of fluorine is highly violent. The the alkanes, when it's substituted with the fluorine, means that chemical reactions are extremely exothermic and violent reaction. That's why that reaction we'll not consider. And another thing, why iodine is neglected means the reaction of this alkanes with iodine is too slow. Okay, it is very slow. That's why that reaction also neglected. So normally for halogenation reaction, we will consider the halogens either chlorine or bromine. So in halogenation reaction, if the hydrogen of the hydrogen from the alkane is substituted with chlorine, we will call the reaction as chlorination. Okay, if it is substituted with bromine, halogenation is also known as their bromination. Okay, so here methane on reaction with chlorine, the reaction occurs in presence of sunlight. Reaction occurs in presence of sunlight. That is what H nu is given here. So when CH4 combines with this chlorine, one of the hydrogen from the CH4, that is from methane, one of the hydrogen is replaced with the chlorine, and which turns to CH3Cl, and thus eliminated hydrogen combines with this chlorine and forms what? HCl. Okay, and again when we will consider the CH3Cl, CH3Cl is chloromethane or methyl chloride. So when we will consider the CH3Cl, again in this compound hydrogen is present. So we can replace that hydrogen also. That means the substitution reaction can be continued until all the hydrogen get substituted with halogens. Okay. So the CH3Cl can again undergo substitution reaction with chlorine. So again when it reacts with the chlorine in presence of sunlight, again next hydrogen is replaced with the chlorine. So one hydrogen is removed from here, means CH3 will turns to CH2. Okay, and to that place the chlorine comes. Therefore we will get the product as CH2Cl2 plus HCl. Okay, CH2Cl2 plus HCl, that is dichloromethane. What is the next product we obtain? Dichloroethane. Okay, sorry, methane, dichloromethane. That is the next product we got. And here also again hydrogen is present. That means the compound CH2Cl2 will again react with chlorine in presence of sunlight. Then again hydrogen CH2 is here, then which is replaced with the chlorine, means CH2 will turns to CH. Okay, will turns to CH. Therefore it become CHCl3 plus HCl. And the CHCl3 is trichloromethane, or another well-known common name of this compound CHCl3 is chloroform. CHCl3 is the formula of compound chloroform or trichloromethane. And then CHCl3, again one more hydrogen is present, which can also undergo substitution reaction. So this chloroform again combines with the Cl2 in presence of sunlight. Then these hydrogen also replaced with the chlorine, and therefore we will get CCl4 along with HCl. And this is what? Tetrachloromethane, or the compound is known as carbon tetrachloride. Common name of this compound is carbon tetrachloride. But this compound again further cannot undergo substitution reaction because there is no hydrogen atom. Clear? So until all the hydrogen gets substituted with halogen, the corresponding alkane that we have taken can undergo substitution. That reaction gets continued. Okay. So this is the first chemical property of alkane, that is alkanes can undergo substitution reaction, where the common substitution reactions of halogens are chlorine and bromine. They are called chlorination or bromination. Second chemical reactions of alkane is combustion reaction. Okay, so combustion, alkanes can undergo combustion reactions, and we know in order to a substance get undergo combustion means which gas is needed? Actually oxygen. The substance should react with oxygen. So alkanes react with oxygen, and we will get the product as carbon dioxide along with water. Carbon dioxide and water are the products we will get when alkanes undergo combustion. And this is the general reaction of combustion. CnH2n plus 2 combines with how many molecules of O2? 3n plus 1 by 2 number of oxygen, which gives NCO2 plus N1 plus H2O. Which gives NCO2 plus N plus 1 H2O. That means this N represents the number of carbon. N represents the number of carbon. So this is the general equation. Just go study this general equation. After studying the general equation, you can write the combustion reaction of any of the alkanes. Okay. So let's take the basic one, that is methane. So methane we know which contains only one carbon atom. So we can substitute instead of N here 1. So in CnH2n plus 2, if we will substitute 1 in place of N, then we will get CH4, right? Plus 3n plus 1 by 2. 3n plus 1 by 2. N is the N here. N, what is the value of N? N is 1. So 3 into 1 plus 1, that is 4 by 2, means we will get 2O2. That is given here 2O2. Then which gives NCO2. N is what? N is 1. That is 1 CO2. So no need to mention that 1. That is why simply we will write CO2 plus N plus 1. N plus 1 means 1 plus 1. Therefore 2H2O. Okay. So sometimes we will get fraction 2. So C4H10, that is when butane undergo combustion reaction, it should combines with 13 by 2 number of oxygen molecule. 13 by 2. Why that fraction comes? Because the N value is 4 here. So when we will substitute here 3 into 4, 12 plus 1, 13. That's why instead of writing a fraction, instead of writing a decimal number, we will write better here. 13 by 2 oxygen gives 4 CO2 plus 5 H2O. In this manner, after studying the general equation, you must be able to write the combustion reactions of all alkanes. So the third chemical property of alkanes is its controlled oxidation. So oxidation means we know addition of oxygen. Then what is controlled oxidation? Controlled oxidation means oxidation in presence of limited supply of air, also in presence of suitable catalyst. And here controlled oxidation of alkanes. In both of this reaction we have taken the same alkane, that is methane. So methane on oxidation in presence of copper at 523 Kelvin and 100 atmospheric pressure, it leads to the formation of CH3OH. What is CH3OH? It is methanol. We will get methanol on oxidation of methane in presence of catalyst copper under these conditions of temperature and pressure. And again, methane on oxidation in presence of molybdenum oxide, MO2O3. This is molybdenum oxide. And in this case, the product will be different. Instead of methanol, here we will get aldehyde, methanol. Okay, so here methanol is formed. That means by this controlled oxidation, by changing the catalyst, oxygen supply remains the same, but by changing the catalyst, the products can be changed. That means from the same reactant, by controlled conditions, we will get the different products by changing the catalyst. So this methane which produces methanol in presence of copper and in presence of molybdenum trioxide, it produces methanol. So normally when we will consider this ethane, we will think either we will get alcohol or aldehyde as the product. But controlled oxidation of this ethane on controlled oxidation in presence of manganese acetate, CH3COO twice, Mn, this compound is what? Manganese acetate. So in presence of this catalyst, it do not produce an alcohol or an aldehyde, which gives CH3COOH, that is acetic acid, which is a carboxylic acid. Okay, so this is what IUPAC name of this compound is ethanoic acid, or we can call it as acetic acid. So please note down the products which is obtained by the controlled oxidation of these three compounds, especially in case of methane, just by changing the catalyst, the entire product gets different. Okay, and ethane also we'll think either we'll get an alcohol or aldehyde, but instead of that we'll get an acid. Okay, And this is the third property of alkanes. Alkanes can undergo controlled oxidation. Coming to the fourth property of alkane, that is isomerization. We have already learned what is isomer and isomerism. So isomerization, it is one of the property of alkane. And why this isomerization is important for alkanes means, isomers means we know there will be straight chain compounds and branched compounds even though its molecular formula is same. So here in chemical properties of alkanes, when we will heat normal alkanes, normal alkane means that linear chain molecules of alkanes, when heated in presence of anhydrous AlCl3 and HCl, anhydrous AlCl3 and HCl, which will converted into branched molecule. Okay, that is what isomerization of alkanes indicate as a chemical property. Isomerism and isomerization is not same exactly. Okay, so please note down this. Normal alkane, so here we have taken is hexane. So hexane we can write as a linear molecule, and here it is represented as CH3 then CH2 4 times. So instead of writing in this manner, you can straight write the hexane. So this is hexane, normal hexane, N-hexane. So this N-hexane on heating in presence of aluminium chloride, anhydrous aluminium chloride and HCl, it will converted into two branched compounds. That is depends upon the number of molecules of normal hexane taken. So there will be two possibility. Either it can converted into this is 2-methyl pentane, 2-methyl pentane, 1 and 2 to the second position if CH3 group is attached. Therefore this is 2-methyl pentane, and this compound is 1, 2 and 3. This is 3-methyl pentane. That means straight chain compound, normal hexane, when it is heated in presence of anhydrous AlCl3 and HCl, which will converted into a branched molecule 2-methyl pentane or 3-methyl pentane. That is what isomerization of alkanes. Next, fifth chemical property of alkane is aromatization. So I told you there will be a third type of hydrocarbon, that is aromatic hydrocarbon. Okay, so double bonded hydrocarbon, double bonded cyclic compounds are known as aromatic compound. Just for a just for the basic understanding, you just keep it in mind. Cyclic compounds, aromatic hydrocarbon, or what is aromatic compounds means they are cyclic compounds, double bonded cyclic compounds. Okay, aromatic compounds are. So the fundamental aromatic or basic aromatic compound that we know is benzene. Benzene, everybody know it's an aromatic compound. So normally first condition, it should be cyclic. To compound be an aromatic, it should be cyclic first. So how to carry out the aromatization of alkanes? So aromatization of alkanes means conversion of normal alkanes, that is the straight chain molecule, is converted into a cyclic compound. How this cyclization can be carried out? That process is known as what? Aromatization. Cyclization of normal alkane using different catalyst or different temperature pressure conditions, which is known as aromatization. So here we have taken the alkane is hexane. So hexane, for the better understanding, it is represented in this manner. You can represent it in the normal straight chain manner also. This is hexane, 1, 2, 3, 4, 5, 6 carbon is present. Therefore this is hexane. So this hexane on heating in presence of chromium oxide, vanadium oxide, then manganese oxide. Okay, heated in presence of these three oxides under defined conditions of temperature and pressure, cyclization occurs. And here, how the cyclization occurs means, in order to join these two carbon, one hydrogen from this carbon and one hydrogen from this carbon is removed, and both will turns to CH2. Then in order to satisfy the valency, they'll form a bond between the two carbon. Okay, and this cyclic molecule, instead of writing here both sides are CH2 and connecting, we can represent in the cyclic manner in this way. That is, the compound obtained is what? Compound obtained is benzene. Okay, so inside that compound there will be alternative double bond is there. So benzene can be represented in two ways. Either this double bond can be started from here, or it can be given to the opposite side. Both are what? Both are benzene. So aromatization means process of conversion of normal alkane into an aromatic cyclic compound. That process is known as what? Aromatization, and which is carried out by removal of hydrogen atom from the 2 terminal carbon atom. Removing hydrogen from the 2 terminal carbon, then we will get the corresponding cyclic compound under defined conditions of temperature and pressure. Next chemical property of alkane is reaction with steam. Okay, so like the previous case, that is the reaction combustion, here also a general pattern is there. So alkanes normally combines with N molecules of H2O in presence of the catalyst nickel and at a suitable temperature greater than 1000. Okay, then it will give N molecules of CO, carbon monoxide, plus 2N plus 1 molecules of hydrogen, 2N plus 1 H2 molecules. Okay, so this is the general reaction. Just study this general reaction, then you can easily write down the reactions using different alkanes. So for example, in case of methane, so methane means see N value will be 1. So methane combines with 1 H2O, that's why we will write H2O here, which produces 1 CO. NCO means 1 CO, that's why CO, plus 2N plus 1. So 2 into 1 plus 1, total 3 H2. Accordingly, you can write down the reactions of next 2 alkanes too. That is, please write the reaction of ethane and propane along with this methane here. And the last chemical property of alkane is pyrolysis. So pyrolysis means when the higher alkanes, especially not the lower alkanes, the higher alkanes which is on heating at high temperature, higher alkanes on heating at high temperature, which will break down into fragments of lower alkanes, alkenes, etc. Okay, the process of breakdown, pyrolysis means make two fractions. Okay, so pyrolysis, the process where higher alkanes which is on heating at high temperature, which will break down into fractions of alkanes or mixture of alkanes, alkenes, etc. So here we are taken as C6H14. This is what? This is hexane. So hexane on heating at 773 Kelvin, which will converted into these 3 sets of product. We'll get these 3 sets of products. Either it can give C6H12 plus H2. That means hexene plus hydrogen gas. C6H12, which is hexene. It turns to an alkene along with hydrogen. Okay. And also it can convert, it can turns to C6H4 when it is on heating, it will break down into C4H8 or C2H6. That means C4H8 is butene. It's an alkene, butene, plus C2H6, we know it is ethane. Okay. Or it turns to mixture of alkanes and alkenes. And here you can see C3H6, which is propene, alkene, and C2H4, which is ethene. Along with this, we will get CH4 methane. Okay. So these are the 7 important chemical properties of alkane. So go through the properties well, especially the general reactions. Please study the general reactions. Okay. So thank you.